Hi, pre-calculus students. Today we're going to talk about section 9.3, the derivative function. So building on what we talked about last time. So here I have the graph of the sine of x. So in yellow here, this is my graph. This is my sine of x right here. And we're going to talk about finding the derivative. So first it asks, what is the value of the derivative at x equals 2? So I have it highlighted already. Here's x equals 2. I went up, put a point, and then here's my tangent line. So remember, derivative is the slope of the tangent line. It's a horizontal line. So that means that my derivative is 0, right? Because the tangent line is horizontal. And it says consider the point at x equals 2. So here's 2, 1 up. Here's my tangent line. And first it asks, is the derivative positive, negative, or 0? Because the tangent line is decreasing, that means the slope of that line would be negative. So then, to determine the slope more accurately, calculate the derivative of f at x equals 2 by the definition. So if I want the derivative at 2, I'm using my f of x, right? The limit is x, delta x approaches 0 of f of x plus delta x minus f of x all over delta x. My function is the sine, so it's at 2, so sine of 2 plus delta x minus the sine of 2. Now we can estimate this limit by evaluating the difference quotient for different delta x's. So I've done that already to save some time. So using this formula, I picked, you see here, smaller and smaller delta x values, and just put these expressions into my calculator, and my calculator's in radians, and I get these values. So then if we want to estimate what the derivative is, or the slope of that tangent line, it's about negative 0.416. And if you look up here, that kind of makes sense. You have that negative slope. It's also already actually written there. All right, so that's the slope. We're going to do the same thing 2 more times with 2 different values, and we're going to pick 2 values from the unit circle. You could really pick anything. I picked pi over 3 and pi over 4. I guess it wouldn't necessarily need to be from the unit circle. You could pick any angle you want, but these are the 2 I picked. And I just did that same thing as I did before, and really these, instead of saying f of this, could say the sine of this, it could say the sine of this, and then I did it for varying delta x values. Okay, when I did that, see the values get closer and closer to 0.5. I did the same thing with pi over 4, smaller and smaller delta x values, levels off at 0.707. So then what I did was, in this table, here were my x values. So first I looked at the graph and got the slope or the derivative when x was pi over 2 and it was 0. And then we figured it out when it was 2, it was negative 4.16. We figured it out when it was pi over 3, it was 0.5. For pi over 4, the derivative or the slope of the tangent line was 0.707. And then what I did was I figured out the sine and the cosine at both of these values. So you could use your unit circle for these 3. You could just put them in your calculator. Okay, so what the big idea that we want to get out of this, though, is we want to figure out what the derivative of the sine is. So what do you notice about the derivative of the sine? So this right here is the derivative of the sine. And how does that compare to the cosine? So what you should be noticing is that the derivative of f of x equals the sine of x is, the derivative is the cosine of x, right? Do you see how these are the same? The derivative of the sine, that's what this is here, is equal to the cosine. This is something that you just need to put in your head. Okay, this might come up. You just need to know that the derivative of the sine is the cosine. All right, so then it says, suppose that f is a function that has a derivative of f prime of x at each point x in the domain of f. Then the function f prime of x maps onto f prime of x for all x in the domain is called the derivative function of f. So what we're going to do, it says find the formula. It says suppose the height in feet for a projectile t lands, or t seconds after launch, is given by this h of t equals 800t minus 16t squared. Find the formula for its velocity t t-seconds after launch. Okay, we've actually done about 2 or 3 versions of this same problem. We're going to come back to it because I want to show you a shortcut. So we'll come back to this graphing part. Take a look at this next page here. So we want to find some formulas for derivatives of constant linear and quadratic functions because we keep having to do them. So there must be a shortcut instead of having to use that definition of derivative every time. So take a minute and look at these quadratics, see if you can notice a pattern. So here's the function, here's the derivative, right? Function, derivative, function, derivative. What are you noticing, and could you generalize it down here? Same thing with linear, same thing with constant. What you should be noticing is if I take the 2 times the 3, that's 6, and then the degree reduces by 1. Think of this as 1 times 6 is 6, and then if the degree reduces by 1 is 0, which is just 6 times 1. And then this is almost like having x to the 0 power, and 0 times 2 is 0, so then that's why that's gone. So if you have something squared in general, it's 2ax plus b. So here, this would be 2 times 9 is 18x plus, this is just 18. This would be 2 times negative 10 is negative 20x, and then plus 7. So the reason I wanted to talk about that was to save us a little bit of time here. If I want the derivative of this would be, now the squared is written second here, so this would be 800 minus 2 times 16, so minus 32t. Now, in the homework, sometimes it will say use the definition derivative. If it says use definition of derivative, you need to go through the limit of the difference quotient. If it says use the shortcut, then you can use the shortcut. Okay, for the linear, you might be noticing, well, these are all just the slope. And it's the same idea as up here, right? If I do 1 times 4, it's 4 and reduce the degree by 1, and then this is like x to the 0, it's just gone. It also makes sense because if you think about having a line, any point that you pick on the line, if you find the slope, it's always, any point along here, the slope is always the same. So if you have something linear, then the slope is just your slope, right? So then this would just be 15. This would just be negative 9. If you have a constant, you might notice, oh, well, these are all zeros, right? So the derivative of a constant is just 0. And the reason for that is, okay, if this is our axis and then I draw this line, it's a horizontal line. Any point along this line, if I find the slope, because it's horizontal, the slope is always 0. Okay, so those shortcuts come in handy. And the idea applies to any polynomial. It's called, I can't write, the chain rule. Let's make that look a little neater. Chain rule. So if I gave you something like g of x equals 4x to the 6th minus 2x to the 4th plus 5x to the 3rd minus 7x to the 2nd plus 8x plus 1, and said, okay, find the derivative. That idea of doing the power times the coefficient, so that would be 24, and then reduce the power by 1, x to the 5th. Minus here, 4 times 2, so 8x to the 3rd, 5 times 3, so plus 15x squared. 2 times 7 is 14x. 1 times 8 is 8. And then the derivative of a constant is 0. So that would be your derivative. So you'll learn more about that when you take calculus, but that's just a little sneak peek. All right, the last thing, graphing a derivative. Okay, so to graph a derivative, and I know that this graph looks like, you're like, probably like, oh my gosh, there's like 9 million things going on here. So first of all, the graph itself, and I might just do it in this color. The graph itself is this, kind of goes like this, and it comes up, and then it comes down like that. All right, that's the curve. And then you'll notice that there are, like here's a point A, and then you can see here is your tangent line is right here. All right, and then there's a point B, a point C, a point D. So what you're going to do is you're going to move along the graph from left to right. For each x value where there's a point, so at A, B, C, and D, you're going to draw the tangent line, which in this case is done for you, and estimate the slope. And then you're going to plot the points. So I'm going to make a table here. So at A, the x value is -5. At B, the x value is -2. At C, the x value is 2. And at D, the x value is 6. What I'm going to do is I'm going to estimate the derivative. That's the slope of the tangent line. Okay, so at -5, so here's my tangent line, and I'm going to think, I just picked 2 points on the line, like here to here, you go up 1/2, the slope is 1/2. Okay, then here's B, right? Here's the slope of the tangent line right here. Again, I'm going to go like from here to here, I go up 3/1, the slope is 3. Okay, here is C is right here. My tangent line is this horizontal one. So then it means your slope is 0. And then D is here. Here's this, it's faint. Okay, pick 2 points. I'm going down 3/1, so the slope is -3. So I'm going to plot those 4 points rather, right? That's 4 points. -2, 3, 2. Whoops, that was the wrong thing, right? All right, let's try that again. -2, 3 would be up here, right? And then 2, 0 would be here. And then 6, -3 would be here. And so I want to graph this. And you might be thinking, well, I could just go like this. The thing is, notice that the original graph here stays above the x-axis. And notice, like, if this were to continue, the tangent lines would always be like 0 or increasing. They never it never turns and is like decreasing. So this has to stay above the x-axis. And then it comes up and then it comes down. And the rest of the graph is decreasing. So any tangent line would be negative. Okay, so then that would be the graph of my derivative. So there are some in the homework where it says, okay, here are these points. Now figure out the slope of the tangent line and graph it. So it's this process right here.